I see the red light. Is it going? This is, yeah, I see the light. This is section 310, where you're adding and subtracting rational expressions. This is Math 1. This is the last section prior to your test. When will your test be? Thursday. Wednesday and Thursday of next week. For you guys on the B-Day, y'all will take it on November 16th. Okay, so your test is next Wednesday. Before we talk about rational expressions, let's go back and review how to add and subtract just basic fractions. 1/2 plus 3/2, or 3 over 2 plus 5 over 4, or 1/2 plus 3/5. Okay, copy those down. Hopefully, if you were doing any of these problems on a standardized test, you'd pick up your calculator and type them in. Okay? I lost my train of thought. If you were doing these normally, you would pick up a calculator and do them. But I want you to be able to do them by hand conceptually so you'll know how to do the problems in this section. Okay? So, everybody's eyes up here paying attention. I gave you a second to copy them down. If my denominators are the same, then simply what do I do to the numerators? Add them or subtract them, whatever the case may be. If the denominators are the same, you don't have to do any work. You get 4 over 2. However, you better not leave your answer as 4 over 2. Meaning in your last step, even on these problems, in your last step, what do you need to do? Simplify. Very good. That's the correct terminology. 4 over 2 simplifies to 2, and so your answer would be 2. Write this in the margin. Don't forget to simplify. If the denominators are the same, then you simply add or subtract. You don't have to do any work. However, in the last step, you can't forget to simplify. Alright, let's talk about this one. 3 over 2 and 5 over 4. Are our denominators the same? No. No. But this one can be multiplied and turn it into this one. This one is a multiple of this one. Okay, 4 is a multiple of 2. So to get them to be the same, what do I need to multiply this fraction by? 2. 2, not 2. 2 over 2. Why is it okay to multiply it by 2 over 2? Technically, what is 2 over 2? 1. And when I multiply by 1, am I changing it? No, I'm not. I'm just rewriting it. So 2 over 2 times 3 over 2 would give you 6 over 4. Right? I changed that fraction into a like denominator. Okay? What is 4 called in this problem? It's 3 letters.
LCD?
Not LCD. LCM. It is the least common multiple. Write that down. Right? Write that down. So many of you freshmen, when I say stuff like that, you need to write that down. Least common multiple. Least common multiple means it is the smallest number that both denominators would go into. 2 would go into it and 4 would go into it. So we needed to change a 2 into a 4. Now we add those up and what do we get?
11 over 4.
11 over 4. You can leave it like that. No reason to simplify. No, not simplify. No reason to rewrite it into a mixed number. Alright, how about the last one? 1/2 and 3/5. Do they have anything in common?
10.
No, they don't have anything in common, right? I can't change a 2 into a 5, and I can't change a 5 into a 2. So I'm going to have to do something to both of them. I'm going to have to multiply this one by something, and I'm going to have to multiply this one by something. Okay? What am I going to multiply the 1/2 by? 5 over 5. What am I going to multiply the 3/5 by?
2 over 2.
2 over 2. Over here I get 5 over 10. Over here I get 6 over 10. I added those up. Or sorry, I multiplied those up. So now I have a denominator that is the same. The LCM in this problem was 10. I add across the top, and what do I get?
11 over 10.
11 over 10 is my answer. Okay? Now, none of these problems are going to be in your homework. None of these problems are going to be on the test because they're too easy. But conceptually, you need to know what's going on here so that you can add up the ones that I'm about to give you. Okay? Questions? Any questions? All right, let's do some examples. Let's see, what time are we at?
5:15.
All right, that took 5 minutes, so here we go. X plus 8 over 4x plus 3 over 4x. This problem is easy. Why?
Because you got like
They have the same denominator. The right way to say it is that they have the same denominator. 4x and 4x. I don't have to do any work. I simply have to add my numerators, add them up. What is x plus 8 plus 3?
X plus 11.
X plus 11 over 4x. And I'm done. Piece of cake. Why was that problem easy?
They have the same
They had the same denominator. You tell me, can you simplify? Can you?
Cancel out the x.
No, because one's a binomial.
Why can't we simplify? One's a binomial. The only thing cancels with x plus 11 is x plus 11. Don't forget that. Nothing cancels. Good question. Quiet. It's too much talking. Alright, let's move on with another easy problem. 6x minus 5 over x minus 2x minus 5 over x. Why is this problem easy? They have same denominators. Ready to go. However, we have to be careful with the negative in the middle. We are now subtracting. Okay? And when we subtract a binomial, right, what do we have to remember to do with that negative symbol? Distribute it. That's the correct math word. Great job. We need to distribute the negative. The negative needs to go here onto the 2x. Where else does it need to go?
The negative 5.
It needs to go onto the negative 5. It needs to go on both of them. If you forget to distribute, you will not get the problem right. Okay? So write it down in your notes. When subtracting, make sure to distribute when necessary. Hello? Yes. Is that just like, does that go on that IM? Does that go on all your IMs? That, please be careful. Okay, that's no problem. In your IM, it has like a please be careful line. Please be careful when corresponding. Never share private information. I don't know, I thought that that was something you were telling me, but I think what it is like, it always goes in your IM. This is the first IM I've gotten from you, so. No problem. I'll send Kohler, no problem. Okay, bye. Take off. Nurse. That was confusing. All right, shh. So here we go. 6x minus 5, right? Then it's going to be minus 2x downstairs towards the front of the school on your left. Guidance and all there. I think there's a sign that says nurse. Minus 2x plus 5. All over x. How come I can write it all over x?
Because it's the same denominator.
Yeah, because you just combined it. You put it all over x. Now what do you need to do?
Simplify.
Combine like terms. Same thing. You're simplifying. But combine like terms. 6x and negative 2x, negative 5 and positive 5, that just gives you 4x over x. 4x over x. Am I done?
No, you can simplify.
You can simplify. Very good. The x's cancel out, and so your answer is 4. Here's your question. If we had not distributed the negative to the negative 5 and made that positive 5, would we have gotten 4 as our answer? No. No, we would have not. Distributing is very important when you are subtracting. Okay, write that down, circle it, start.
How come the negative doesn't go to the x?
The negative doesn't go to the x because it stays on the top. Good question. Stays on the top. Alright, here we go. Now what do you think is going to happen to our denominator?
It's going to change.
Yeah, they're not going to be the same. It's not going to be quite so easy. Let's try the first example. 1 over 3x cubed plus 5 over 4x to the 4th. first question is either on paper or in your head, you have to figure out what the LCM is. What is the least common multiple? What is the smallest number that 3 will go into, that 4 will go into, that x cubed will go into, that x to the 4th will go into? What value will that go into and that go into? Scarlett? 12x to the 12th is what she says. Is that right?
Whoa.
12x to the 12th is a common multiple. It's not the least common multiple. We want the smallest value of x that x cubed will go into and x to the 4th will go into.
Oh, sure.
It's 12x, but what is it 12x to?
To the 4th.
To the 4th. Write that down. My LCM is 12x to the 4th. That is the least common multiple. It's the smallest value that both of those will go into. Alright? So what am I going to have to multiply this one by to get to 12x to the 4th? What am I going to have to multiply this one by to get to 12x to the 4th? What is this one going to be?
4x.
4x over 4x on the top and the bottom. What about over here?
3.
3 over 3. How come I don't need an x on that one?
It's already x.
It's already to the x to the 4th. I'm already there. Okay? So let's finish this out. 4x plus 15 all over 12x to the 4th. I kind of just put it all together. It kind of flowed together. Can I cancel anything?
Yeah.
Careful.
They're binaries and they're not the same.
That's right. Can I factor anything out of 4x plus 15?
Sure can not.
Sure cannot. There's no GCF, so you cannot factor anything out. You're done. Questions? Yes, that's your final answer. Raise your hand if you have a question.
I was
Esther?
I was kind of confused, like when you said the LCM.
LCM, least common multiple.
Yeah, but now I get it.
Now you get it. All right, let's try another.
Hey, no.
Yes, Kristen?
So like whenever you get the LCM, it's not what the variable go, like the LCM of the variable, to the exponents or whatever. It's what, when you multiply it together, it's what the x.
Think about it like this. 12x to the 4th, 3x to the 3rd will go into that, right? And 4x to the 4th will go into that. It's the smallest value that both denominators will go into. Okay?
I didn't know how to ask that.
That's okay. Did I answer your question?
Yes, sir.
All right. How about this one? Tell me what the LCM would be.
35.
35. All right. What would the LCM be now?
I have no idea. X squared minus 4.
Let's do this problem. This is a good problem. Write it down. What's the name of the game? You can't figure out the LCM first. What do you need to do over here? You've got the difference of perfect squares. You better factor that one. Open the door. X minus 2 and x plus 2. Right? That's what that denominator factors into. Now, can you tell me what the LCM is?
X minus 2.
X plus 2 and x minus 2. The LCM has to be both x plus 2 and x minus 2. Do I need to multiply this first fraction by anything?
No.
You sure?
Wait.
Is my denominator okay?
No.
It needs to be x plus 2 also.
X plus 2 over x plus 2. Why do I have to do it on the top and the bottom?
Because it's not going to be equal.
That's right, it's not equal to 1. I have to do the top and the bottom. On the top, I simply get x plus 2, right? Over x plus 2 and x minus 2. No, they would cancel, but we haven't added yet. The whole goal is to add. Plus 3 over x minus 2 and x plus 2. Are our denominators the same?
Yes.
Why didn't I have to multiply this one over here by anything?
It was already there.
It was already there. Right? And I didn't have to do anything. It was already there. It was already our LCM.
How'd you get that though?
I factored it. I factored it into x squared minus 4 and it gave me x plus 2 and x minus 2. Okay? So now that our denominators are the same, can you tell me what the answer is going to be?
4
X
over
plus
x.
5.
X plus 5 over.
X plus 2 and x minus 2.
Why don't I go back and say x squared minus 4 on the bottom?
It's not simplified.
You need to leave it in factored form. Write that down if you don't remember that. Always leave your answer in factored form.
Would you accept x plus or minus?
That's not the answer. That's not. You're mixing that up. That would be excluded values. We're not talking about excluded values here. Okay. Question, Hester.
I'm like really confused.
That's not a question. Yeah, that's a statement.
That's an
I
obvious.
mean, I get the difference.
Listen, here's the good news. You've been exposed to it today. You're going to have a few problems for homework. Okay? We're going to be able to talk about it on Thursday. We're going to be able to talk about it on Monday. And then Monday we'll review, and your test is on Wednesday. Okay? So instead of you seeing it for the first time on Thursday, today's Tuesday, I'm going to reteach it on Thursday from scratch. Okay? We're going to do some problems with a partner. We'll do some problems on the board, and you'll get more practice at it. I do not. I'm out. Your homework is over here. Workbook and textbook. This is today's homework, Tuesday. Textbook 167, workbook 189. Let's see, hit stop.